Okay, now for example 3. This program is a pretty good example of using arrays and beep commands. An array is like making one variable that holds a whole list of strings or numbers. This way, that way if you're making a program that like held your shopping list, you wouldn't have to make a variable for each item like item 1, item 2, item 3. You just make an array that says items and then followed by the number of items that you want in the array in brackets. The data command is where you type in the keys used to beat the piano. You don't have to space these things out like they did. You can put it all on one data line because all the same, it's going to end up in the array. Under data, you see that the variable KCNT, that stands for key count. If you count the data, you'll notice that we only have 17 keys, but it says 18. I'll get to that in a second. Under the key count, they created a string called $. When creating an array, you'll use the dim command. You notice that key count is in brackets next to the $. That's because when making an array, you have to tell the computer how many items you want to be stored. You know, we talked about that earlier. And you have to put the number of items plus 1. And that is the reason for the 18 in key count instead of 17. I believe the reason that you add one more number to it is because there has to be space in the array for like index information or something like that. You just want to keep this in mind or else you'll get syntax errors. It's important when dealing with arrays and for two-step next that you remember that computers use 0 as a counting number. It's weird, I know, but rather than be bothered with always making your counting variable 1 less, it's easier to just subtract 1 from it after the 2 in the for two-step next. Okay, let me briefly explain for two-step next. You've already encountered if, then, else, and while, so this should be starting to make some sense to you. The code reads for 0 to 17, read our data into the array. We do this so that we don't have to declare each piece of data in our array like we would a variable with the equal sign on the right followed by the number you want to put in it. Read command brings up whatever is in the data and stores it in whatever you tell it to. This is the step in our for two-step next. The next command will bring us back up to 4 and increment the variable I by 1. So now instead of 0, now I will be 1. It continues doing this until I reaches 17, or key count minus 1. From there, it'll just keep running the code past next. I'll certainly have to do more videos on the arrays and for two-step next, but you'll get it. Now you can see they declared variables F and V. I know those names are terribly descriptive. They stand for frequency and voice. 96 is the number of a semitone for a beep command. A semitone is the difference between a white note on the piano and the black note right next to it. If you look at your manual under beep, it'll tell you all about this command and what the numbers mean. Voice is set to 22, which is, as you can guess, the number for the piano sound. You can change this into something less boring than a piano if you want. Finally, we get down to business. When you see the @loop label, you know the real program is about to start. All of this was just overhead. Variables needing to be declared, data needing to be read, such. There's some drums in this program too, right? Let's talk about the drums. Right off the bat, they said button is that's a long word. Let's just set it to B. Then they used some if, then, else statements to tie each directional button to a sound. There's a kick, a hi-hat, all sorts of good stuff. They even threw in the X button, number 64, to end the program with. How thoughtful of them. After that, they get back to the subject of the keys. How we're going to tie the keys to the touchscreen to the actual sounds. They start with the N key function, which returns what key you're pressing on the touchscreen. They really thought of everything. To shorten things up, they declare it as a string variable called K $. First off, they want to make sure when no keys are pressed, you can still use the drums. So if if K $ equals blank, then go back to at loop and try again later. If a key is pressed, then we set I, our counting variable, to 0. Then if K $, our key pressed, equals any of the keys that we've stored in our N $ array, then go to at play. Before we go off to play the sound, let's talk about how we're checking each piece of data in the array with this at K loop. First, it's going to compare the key press to the data that is stored in the N $ slot 0, which is our first key, the question mark. Then we increment our counter with I equals I plus 1, and after that ask if I is less than the number of keys. We have to then go to at K loop and check the next slot on the array. After I equals 18 and the checking of the keys is all done, it goes back to at loop so that you can use the drums. All this happens so fast, it almost seems like it's checking for all these things at once, but it really isn't. Lastly, let's talk about at play. We make a variable called P, that is the frequency times the counter, I minus 96. Now, why the minus 96? It's so that I equals 1, then P will end up being 0 and playing the C note when you push the question mark key. Then when I equals 2, P will equal 96 and play C sharp, and so on and so on. Looking at beep, you understand now why we declared those V and P variables in the beginning. The reason you do these sort of things in the beginning rather than right when they're needed is so that when you want to make changes to the voice of the beep or the octave of the notes, you can do so from the start of the program without having to scroll all the way down. If you practice this, it'll pay off whenever you have a really long program and you want to make small adjustments to values.